Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video provides practice in conducting hypothesis testing and constructing confidence intervals for two population proportions. Let's get started. The example we're going to look at today involves a New York City marathon. So in a recent iteration of this huge event, 25,221 men finished the marathon, 253 dropped out. 12,883 women finished, and 163 women dropped out. So the questions were asked are pretty typical standard questions, and we've seen questions like this before. The claim that we're going to be investigating is that men have a lesser tendency to drop out than women. Now, I don't know what man actually came up with this, okay? It's certainly not me, because I'm smart enough to know, okay? I've been around. There's plenty of women out there who can kick some serious can, and I'm not going to mess with that, okay? So, some guy here is cruising for a bruising, and, regardless of what the statistical test says, he's going to get it. But let's just see if it's mathematically justified. So first of all, we're going to form our hypotheses. So as always, the first thing we think about is the claim. The claim here is that men drop out less than women. Okay, since the men are mentioned first, they're going to be sample 1. So they're going to have the subscript 1. And then the women are mentioned second, so they're going to have the subscript 2. So the proportion of men dropping out is less than the proportion of women who drop out. So 1 is going to be less than 2. Or we could say that 1 minus 2 is going to be the 0. Or actually, it's going to be less than 0, because the proportion of the men, the P1, is less than the proportion of the women. That's what's claimed. The null hypothesis, by definition, is a statement of equality. So here we have the null hypothesis written here. And the alternative hypothesis, typically we take the claim for that, unless there's some semblance of equality. Here there's no semblance of equality with our claim, so we're just going to adopt that as our alternative hypothesis. And that inequality sign, the less than sign, is like an arrow pointing to the left, and that indicates that we have a left-tailed test, a one-tailed test on the left. What's our test statistic? Well, we could use that obnoxiously hairy equation that we saw in an earlier mini lecture, or we could just go into StatCrunch. So let's do StatCrunch. In StatCrunch, go to Stat, Proportion Stats, to Sample with Summary. In the options window that appears, notice we're going to put our stats in for the men are the first sample because they were mentioned first in the problem statement. The women are the second sample because they're mentioned second. But notice how we've got a different number here for our total observations. That's because we've got to add together the men who drop out with the one who finished. That's the total group that we're looking for. And that's the number we want to put here under total number of observations. Likewise for the women. Okay, you've got to take the number that dropped out, add it to the number who finished to get the total number that were in the race. And then, of course, make sure your hypothesis test fields match. Typically, this 0 here for the quote-unquote claimed value is just going to stay the way it is. You're typically not going to need to change that. But make sure that this inequality for your alternative hypothesis is matching. Then go down and press Compute, and out comes your results window. Your test statistic, as always, second to last number there in your results window. P-value, if you're asked for the p-value, just go to that same results window and take the last number. That last number there in the table, always the p-value. Are we going to reject the null hypothesis or fail to reject the null hypothesis? Well, in this instance, we're going to use the same criteria that we've always used. So for outside the region of rejection, fail to reject. For inside the region of rejection, we reject. Here's our results window that we saw just a moment ago. And if we use that p-value there on the end, p-value of 0.0106, we're testing at a 1% significance level, so we're just barely greater than that alpha, but it doesn't matter how much greater you are. Outside is outside, and so because we're outside the region of rejection, we're going to fail to reject the null hypothesis. Alternative with the test statistic, look at our test statistic here, negative 2.30, and the boundary for our critical region here, negative 2.326. So negative 2.30 is just barely outside the region of rejection. But it doesn't matter if you're just barely outside or if you're far away outside. Outside is outside. And so, because we're outside the region of rejection, we fail to reject the null hypothesis. What do we conclude from the hypothesis test? Well, we failed to reject the null hypothesis, so that means there is or there is not sufficient evidence. What do you say? Well, I hope you said that there's not sufficient evidence. If we reject the null hypothesis, there is sufficient evidence. But here we failed to reject the null hypothesis, therefore there's not sufficient evidence. Do we have a one-tailed or a two-tailed test? Well, we had a one-tailed test on the left. A one-tailed test means we're going to use the language that says support the claim. So there's not sufficient evidence to support the claim, and that's the combination that we get with answer option B. Again, notice the pattern that we learned with the one-sample hypothesis testing is going to follow us here with the two-sample hypothesis testing. Exactly the same. What is the appropriate confidence interval? Typically you're not going to be given a specific confidence level. If you are given one, by all means use it, but typically you're going to be asked for the appropriate confidence interval, which has the appropriate confidence level. What they're doing here is testing your knowledge that the appropriate confidence level when you have two samples or two populations is going to be 1 minus 2 alpha. So here, back in our options window, notice I've got the same summary stats up here at the top, but instead of that radio button being clicked for hypothesis test, now it's being clicked here for the confidence interval. And notice my confidence level here. Alpha is 1%, but that confidence level is not 99%, it's 98%. Because again, when you've got two samples, two populations that you're dealing with, you're going to be looking at 1 minus 2 alpha. So 98% is the appropriate confidence level. Out comes my results. I read my upper and lower limits there on the end of my table, and I can use those to construct my confidence interval. So for rounding to 4 decimal places, this is what we come up with. What do we conclude from these results? Well, remember, the question we're asking when we're looking for a conclusion from a confidence interval on two populations is 0 inside or outside the confidence interval? Here, 0 is, it's just barely, it's inside, just barely inside, but again, it doesn't matter, how far you are from that fence. Inside is inside, so 0 is inside the confidence interval, and therefore it could potentially be the difference between those two proportions, and that means the proportions would then be the same. So because 0 is inside our confidence interval, we must conclude there is no statistically significant difference between the proportions of men and women who drop out of the New York City Marathon. Notice here in this instance we reach the same conclusion that the hypothesis testing. That's not always the case with proportions, okay? So you have to be careful when you're looking at CIs with proportions, because sometimes they give you a different result. Here they give us the same result. So now we've got twice the mathematical justification for some guy to get his can kicked by a woman. And I don't know about you, but I'd love a ticket to that show. I'd pay money to see that. That'd be some pretty good entertainment right there. That brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.